Hello everyone, I hope that you all are doing well. Today we solve a very interesting question. This question is asked in most of the times in CSR net exam and other competitive exam. Okay. In these questions we have to calculate what? We have to calculate the sum of this series, and an is defined in this way, n plus 1 by n. Okay. If we denote this sum as s, we will get this term. Okay. And if we will put the value of a n plus 1, a n plus 1 nothing but n plus 1 plus 1 by n plus 1, and here n factorial is given, so it comes in the denominator. Okay. If we will further simplify this term, we will get what? We will get n plus 1 by n factorial, and here n plus 1 times n factorial gives n plus 1 factorial, this term. Okay. Further, if we will simplify this term, it gives n by n factorial, where n get cancelled out, so it gives n minus 1 by n minus 1 factorial, and 1 by other term is 1 by n factorial. Okay. And the third term remain as it is. Okay. So finally we got three terms, first one, second one, and third one. So if we will separate these terms, we will get three sums, first sum, second sum, and third sum. So first of all we have to calculate this sum separately. Okay. First we will consider the first sum. First sum takes the form minus 1 to the power n plus 1. This term will come 1 by n minus 1 factorial, 1 by n minus 1 factorial. Okay. So this thing is nothing but summation n from 1 to infinity minus 1 to the power n minus 1. If you will think that how minus 1 to the power n plus 1 is same as minus 1 to the power n minus 1, this is a identity. If we will put value n equal to 0, it gives minus 1, it gives also minus 1 to the power minus 1, which is also minus 1. If we will put n equal to 1, it gives 2, which is 1, and in the right hand side it gives 1 minus 1 g0, which is also 1. So every time minus 1 to the power n plus 1 is same as minus 1 to the power n minus 1. So we in place of minus 1 to the power n plus 1, we put minus 1 to the power n minus 1. But one student also asked that why we put these things, because we want to same these terms, these exponent and the n minus and this factorial, both should be same, then only we can apply a formula. Okay. So here if we take n in place of n minus 1, then n should start from 0, because when n starts from 1 it gives 0 factorial, and it also in the exponent also it is coming 0. Okay. So if we put n minus n in place of n minus 1, so this summation should start from n from 0 to infinity, which, and it takes the n from 0 to infinity minus 1 to the power n divided by n factorial, which is nothing but e to the power minus 1. How e to the power minus 1? It comes from the exponential series formula, e to the power x equal to summation x to the power n divided by n factorial, and n starts from 0 to infinity. These are the main point, n should start from 0 to infinity. Here in this problem, here in place of x it is coming minus 1, so it e to the power minus 1 is coming. Okay. I hope that you all understood it very well. Let us move to the second sum. Second sum is 1 by comes the for 1 by n factorial associated with minus 1 to the power n plus 1. Okay. Takes this form. Second sum takes this form. Okay. If we will break this minus 1 to the power n plus 1, here our target is convert this exponent to n, because here n factorial is coming. Okay. But in the previous sum it was coming n minus 1 factorial, so our target was to convert the exponent to n minus 1. But in this case our target is to convert this exponent n plus 1 to n, so we have to break it. If we break it, it takes the form minus 1 to the power n into minus 1. Okay. Then it takes minus times of this series, minus summation n from 1 to infinity minus 1 to the power n divided by n factorial. But here we cannot apply the formula directly, because here n starts from 1, n starts from 1 to infinity. But if you look the exponential series formula, n should starts from 0 to infinity. So one term is missing, which is for n equal to 0. So we have to add and subtract. If we will add, it comes from n from 0 to infinity, and but we have to subtract that 1 also for n equal to 0. For n equal to 0, this terms is gives 1, so we have to subtract minus 1. Okay. Then we will get this formula. This sum is e to the power minus 1, which I have also previously used in this case here. Okay, so it gives e to the power minus 1 minus 1. If we will multiply the minus 1, we will get 1 minus e to the power minus 1. Okay, let us move to the second sum. Second sum contains the term 1 by n plus 1 factorial associated with minus 1 to the power n plus 1. Okay, here these two things are same, but the sum starts from n from 1 to infinity, but we have to also convert n plus 1 n here exponent n plus 1 and the n plus 1 factorial to n. If we will place n plus, if we will place n in place of n plus 1, then the summation starts from 2 to infinity, because when n plus 1 here and n starts from 1, if we will put n equal to 1, it will gives what? It gives 2 now. For that reason, if you put n in place of n plus 1, there the summation should start from 2 to infinity. Okay, then we cannot apply the formula, because here the missing terms are n equal to 0 and n equal to 1. For n equal to 0 it gives 1, and for n equal to 1 it gives minus 1. So we have to subtract these two terms, add and subtract. If we will add, then the summation starts from n from 0 to infinity, and we have added two terms, for n equal to 0 and n equal to 1. So we have to subtract these two terms. Okay, but these two terms are not giving much more things, because 1 minus 1 is 0. Okay, so this minus 0. So the summation starts from n from 0 to infinity, minus 1 to the power n divided by n factorial. So we can directly apply this series nothing but e to the power minus 1 and minus g0. So we get finally e to the power minus 1. So finally we have calculated the three sums. If we will add all these three sums, we will get s equal to e to the power minus 1 plus e to the power 1 minus e to the power minus 1 plus e to the power minus 1. Here e to the power minus 1, e to the power minus 1 cancel out, so it gives 1 plus e to the power minus 1, so it gives 1 plus 1 upon e. So the answer is 1 plus 1 by e. Okay, option B. I hope that you all understood it very well. Thank you all very much. See you all soon again.